Hey everyone, today I'll walk you through the technical architecture for the conversational AI application, which I built for performing analytics on the GitHub repositories. The application I built follows a four-layer architecture. A Streamlit for the web interface, the chatbot application layer, then specialized GitHub for GitHub MCP client for communication, and followed by that, most importantly, I have integrated this with external services, including the official GitHub MCP server and Gemini 2.0 Flash. Yeah, now let me break down the key technical decisions which I have taken to construct this application. First, the user interface layer. I chose Streamlit for development and the chat interface support. Then for the application logic layer, I have constructed this GitHub chatbot class to handle the core intelligence. First of all, it processes the natural language queries. Then it consults Gemini 2.2 Flash for the tool selection. Then it orchestrates the GitHub operations and formats the response for users, right? Then the communication layer, this is where the architecture gets sophisticated. Actually, I built this custom GitHub MCP client to manage the Docker container communication, implements the MCP protocol, and most importantly, it handles the async IO event loop challenges through the dedicated threading. Yeah, here is how a query flows through the system. First, the user types a natural language query, like maybe read me from my repository or any repository name, right? Then the query reaches the chatbot application layer. It retrieves all the available GitHub tools from the GitHub MCP server. Then the complete context is sent to Gemini 2.0 Flash for the analysis. Then Gemini returns structured JSON with the selected tools and parameters. The MCP client executes the GitHub operations via Docker. Then the result is flown back through the layers and displayed it in the chat interface. This is my Docker, uh, Docker for desktop, where I have deployed my GitHub MCP server container. And this is how the application will look like immediately after you run the Streamlit run app.py. This is how the window will look like. So I also given a provision to connect to the MCP server from the user interface. Now let me click on this connect to MCP server to connect to the GitHub MCP server. The insights that I wanted to grab is from one of the repository which I have already created an year ago. This is a repository which will do some fine tuning on the Microsoft V2 model, an year-old repository. Now I also prepared some of the questions what I wanted to try for this particular demo. So let me grab those questions. So one of the question would be to create a feature branch named uh, feature slash config changes in the from the repository from the given repository. So immediately after I click enter, it will start processing behind. So it is processing my request. Let's see if it is creating a branch. Yeah, now it says that it has created a new branch named feature slash config changes, right? So let me go to the repository. Let me refresh this. Yeah, now I can see that it has created this feature slash config changes branch, right? Then my follow-up question would be to from that particular branch, I wanted to create a file named llm slash config dot llm underscore config dot py, and also wanted to introduce some configuration named temperature, right? So quickly I'll show you whether that particular file is present or not. Okay, let me go to the branch that it has created, feature slash config py. So has it created, does it have llm underscore config? No, it does not have such file. Okay, let me click enter. It is processing the request. Yeah, it has done something. So it says that it has created a new file named llm underscore config.py. So let me go and refresh. Yeah. Okay, immediately it has given a notification for the pull request as well. So yes, it has created this file. It says it's llm underscore config.py, and then it has introduced this variable temperature equal to 0.7, right? Now that I wanted to create a pull request for the changes that it has done. So let me go and give this user query. So I wanted to create a pull request to merge the changes from the feature branch to the main branch. So let me click enter. Yeah, it is still processing the request. Yeah, it has processed and given lot many logs. Right, okay, let me go here. Let me go to this repository. Yeah, I can see some pull request which has been created. So open now, right? Yeah. So this application can create a value proposition for the engineering leaders. Say, suppose anyone wants to get some metrics which can give some insights on the latency of the PR approval, or else the trying to identify the productivity of the team, right? The number of commits they do and the number of pull requests that has been created. And also from that, they can try to get some pattern on the way, pattern on the commit git commits, or else also on the pattern on the review the senior developers they do, or whenever the junior developers check in some changes, right? So for those type of I think those type of value proposition can be created. I have also attached the GitHub repository in the comments below. Please do have a look into it and then let me know your thoughts on this. Thank you. Thanks for watching this video.